All right, so for the longest time, we've kind of treated AI models like, super smart calculators. You give them a problem, they spit back an answer. Simple. But what if we could flip that whole relationship on its head? What if our applications, what if they could think for themselves and decide when they need a hand from the AI? Well, that's the core idea behind this protocol called MCP sampling. And honestly, it could completely change the game for how our backend systems work. So here's how we're going to break it down. First, we'll get into the big idea, this concept of flipping the flow. Then, we'll look at how it builds in these really smart human checkpoints for safety and control. After that, we're going to peek under the hood a bit at the anatomy of a request to see the nuts and bolts. And finally, we'll explore what this all makes possible, some really powerful new stuff. All right, let's get right to it. At the absolute core of MCP sampling, there's this one simple but honestly pretty profound question. Think about it. The way things usually work, our AI models are just passive. They just sit there waiting for us to tell them what to do. The whole thing starts with the user, right? But MCP just totally flips that script. It asks, hey, what if the system could be the one to start the conversation? What if your server, right in the middle of doing its job, could realize, uh-oh, I'm stuck, and actually raise its hand and ask for help? And this right here is the fundamental shift. Look at the traditional flow. Your server is basically just a dumb pipe, right? It just blindly shuffles requests from the client over to the AI and back again. But with the MCP flow, the server suddenly gets, it gets agency. It's no longer just passing notes. It can be in the middle of a process, hit a wall, and decide all by itself that it needs some help, either from a human or an AI. It's not just a pipe anymore. It's an active participant in the whole thing. Okay, so I know what you might be thinking. Giving your server a brain sounds a little risky, maybe. But this is where it gets really brilliant. This new flow doesn't cut the human out of the loop, just the opposite, actually. It pulls them in a much more meaningful way by creating these super important checkpoints for control.
So this isn't some scary black box where the AI just goes wild. Let's walk through it. Imagine your server gets a new support ticket. It knows it needs to categorize it, but isn't sure how. So it starts a request. But, and this is so important, before a single thing gets sent to the AI, a human gets to look at the prompt. That's checkpoint number one. You can edit it, approve it, whatever. Then the AI gives it suggestion, and you get a second checkpoint to review the AI's answer. Only after you say, yep, looks good, does the server actually use that information. Nothing happens without a human giving the thumbs.
Yep, 2. That's the magic number here. 2 separate, distinct moments for a person to jump in. This whole human-in-the-loop twice design is what stops the system from running off with a bad prompt or acting on some bizarre AI response. It's the ultimate safety net, and it's what makes this whole idea practical for things you really can't mess up, like legal documents or financial analysis. So when you put it all together, you get these 3 huge benefits that really make the whole system click. You get servers that can actually start thinking for themselves. You get that built-in human review we just talked about, and you get AI use that is structured and something you can actually repeat reliably. It basically takes AI integration from being the Wild West of just, throwing prompts in a model and turns it into a real, traceable, and dependable engineering practice. Okay, so how does this actually work under the hood? I mean, how does the server tell the client what it needs in a way that's understood perfectly every single time? Well, it's not just some casual chat. It's all built on top of a standardized protocol, which is what makes the whole thing predictable and, reliable. All the magic happens through this one single standard message type sampling/create message. The best way to think about it is it's not a conversation. It's more like a really detailed order form. It's a super structured way for the server to say, hey, here's exactly the kind of help I need from the AI right now. And this order form is packed with all the details you'd need. Of course, it's got the conversation history for context and a system prompt to set the AI's tone. It even has controls for things like randomness, the sampling parameters. But the real game changer, the part that's especially clever, is this little field right here, model preferences. Now, this model preferences field is so smart. See, your server doesn't know and frankly shouldn't care if the client is hooked up to GPT-4 or Claude or some little open source model. So instead of asking for a specific model by name, the server just states its priorities. It can basically say, look, for this particular task, intelligence is what matters most. Or maybe for another task, I don't care how smart it is, I just need this done fast. So, for example, let's say your server is doing some really heavy data analysis. It could send a request where intelligence is cranked way up, like to a zero point 0.9. The client sees that and goes, okay, got it, this job needs the big guns. And it'll automatically route the request to the most powerful model it has available, even if it's more expensive or a bit slower. It lets you dynamically pick the right tool for the job every single time. Okay, so that's the tech, that's how it works, but so what? Why does this all matter? What can you actually build with this? Now that your backend has, a brain and a voice.
Well, this whole setup unlocks these powerful agent-like behaviors that, frankly, were just too risky or complicated to build before. I'm talking about things like a system that can take a totally unstructured, messy email and pull out clean, structured data from it. Or a workflow that sees a complex support ticket come in and not only flags it, but also suggests which engineering team should handle it. You could even have AI-assisted code reviews where the system suggests refactors. And in every single one of these cases, the pattern is the same. The machine does the grunt work, and a human gives that final, crucial sign-off.
When you step back, you realize this is about so much more than just writing better prompts. The best way to describe it is as programmable delegation. It's about building a truly collaborative system where everyone, the AI, the server, and the human, all have a specific role to play. The server delegates the stuff it can't do, the AI comes up with a possible answer, and the human gives the final approval. Each one is playing to its own unique strengths. And that shift from thinking of AI as just a tool to thinking of it as a collaborative partner, that's a really big deal. When our systems can actually pause, think for a second, and ask for help when they need it, it fundamentally changes what's possible. So the real question this leaves us with is, what kind of new, truly intelligent and reliable applications are we going to build now that we have these capabilities?